Hi, this is the fourth tutorial in the Spinal Pathways series, and we're going to be discussing the corticospinal tract. The corticospinal tract is the pathway which conveys axial and limb motor control. In plain English, this is the pathway that lets the brain control the movement of muscles. So this pathway begins in the precentral gyrus, which is the primary motor cortex. Just to clarify, the last two pathways we discussed, the dorsal column medial lemniscus and the spinothalamic tract, projected onto the postcentral gyrus. This pathway, however, arises from the precentral gyrus. See the handwritten tutorials on brain anatomy for more information on these two gyri. So our journey begins with two neurons. One will ultimately innervate the axial muscles and the other will innervate the limb muscles. They leave the cortex by descending through the internal capsule and into the brainstem. So I'll draw the brainstem here. Here is the thalamus, which is not involved in this pathway, the midbrain, the pons, and the medulla. As the pathway descends into the medulla, 75 to 90% of the fibers decussate. These are the fibers that will innervate the limbs. The axial fibers don't decussate here. This decussation is one of the biggest decussations, so it's worth looking at it further. If we take a cross-section through the medulla here, we will see something like this. The fibers cross to the other side of the medulla, and we call this the decussation of the pyramids. The pyramids are the corticospinal tracts as they run through the medulla. For this reason, the corticospinal tract is sometimes called the pyramidal tract. After leaving the brainstem, the fibers run down through the two corticospinal tracts that we saw in the first video in the series. These are the anterior corticospinal tract and the lateral corticospinal tract. When they get to their target level, the fibers of the anterior corticospinal tract finally decussate through the anterior white commissure before synapsing to a neuron in the anterior horn of the grey matter. Conversely, the fibers of the lateral corticospinal tract have already decussated at the level of the pyramids. As such, when they get to the appropriate level, they just synapse onto a neuron in the anterior horn. It's worth noting that the neurons in the cortex are known as upper motor neurons, and a lesion anywhere in these fibers from the cortex all the way down to the anterior horn are known as upper motor neuron lesions. This is very important clinically, but beyond the scope of this tutorial. These neurons in the anterior horn, which are intuitively called anterior horn cells, then project to the limb muscles and to the axial muscles. Again, I'll just point out that these neurons are known as lower motor neurons, and as such, a lesion anywhere between the anterior horn and the muscles would be known as a lower motor neuron lesion. So in summary, the corticospinal tract is a two-neuron pathway. There is an upper motor neuron, which arises in the cortex, and a lower motor neuron, which arises in the anterior horn. The limb pathway decussates at the pyramids in the medulla, and the axial pathway decussates through the anterior white commissure in the spinal cord. And that concludes this tutorial on the corticospinal tract. If you've enjoyed this tutorial, please help us produce more by making a donation at www.handwrittentutorials.com.